Okay, thank you all for coming. This is my talk. It's about multi-environment deploys with Terraform as application glue. So to give some context for that, then I'm talking about deploying primarily microservices. And there's a few reasons why we might have different environments, but I'm going to be thinking about the promotion process, so how you manage your dev environment, your test environment, staging, and then production. And then also how you make sure that what you deploy is consistent across all of those things. The other part of the title, application glue, is maybe less straightforward. I've been trying to describe this concept accurately, which seems a bit tricky. So we're talking about packaging services, essentially, with Terraform. I'm not talking about like packaging a binary, not really talking much about the OS layer, but like what are the other things that you need in order to get your service to work. And Terraform will be able to help us with some of those things. Okay, so to give you a bit of background for where I'm coming from, primarily most of the projects that I work on with OpenCredo, they're platform engineering projects. So we do a lot of things like setting up AWS accounts or GCP, maybe standing up Kubernetes. And for those things, we use Terraform. I think on every project, maybe since I joined OpenCredo, we've been using Terraform to do things like that. And when we do use Terraform in that case, then when we use Terraform in that case, then we check in our configs into Git, and we also set up pipelines to do the deployment. So as soon as we check in new code, then we'll be able to deploy it into one or more environments. So that's not completely straightforward. There are some like tips and tricks. This won't be in this talk, but there is a previous talk that our CTO, Nikki, has done. She's right there. Her talk is called Terra Services. It's about structuring your Terraform files so that you can like deploy them more easily and split them up and do like independent deployments. I also happen to know that Seth is talking more about infrastructure pipelines in a following session. So maybe check that out. For the purpose of this talk, what we want to say is like Terraform has been really good for deploying infrastructure. It works well in pipelines. So that approach is pretty good in general. This thing here is more what I'm going to talk about. This is now in like the CICD domain. This is a representation like in Travis about what we think some of the best practices are. So we have the testing. So the testing is like we're trying to move it to the left. And then after we've done the testing, then we can bake an immutable image. That might be with Docker, or it might be actually baking an EC2 image. Usually we do tend to use Docker builds these days. And then once you have that thing, then you can deploy that package, like the Docker image, or maybe it's a Kubernetes manifest. You can deploy it to like multiple environments. So you'd start off with a test environment, and then you can use exactly the same thing to deploy into production. So until now, like this pipeline works pretty well for simple apps, just something like this. But things are actually not that simple. So with most apps, then they don't stand alone. It's not just one process that's stateless, but they have other things surrounding it. So that might be things like a database. It might be like a DNS record, or even firewalls, some stuff that sits in front of the app. And then we might want to select different profiles, or we might just have a bunch of config that we need to feed in for every environment. And it can be tricky to keep those things kind of in line with the app itself. So when I was working on a previous project, we had a setup which is very much like this, running in Kubernetes. So actually it was OpenShift on that project. But the service databases that were supported were using RDS, which is the managed service from AWS. And that is outside of Kubernetes, and you can't manage it with Kubernetes manifests. So because on that project, we actually had quite a few microservices. And it was, I guess it was towards the start of the project, and these things were changing a lot as well. So we had many services, they were changing a lot, so we also had like many environments, we were doing deployments, and like a lot of those deployments were failing. And when they were failing, the number one kind of symptom we would see is that the config that was in the app just like didn't match with what was in the environment. And that sucked because it was some kind of stupid error that we had to spend time debugging. We had to go and fix it manually, and it was really annoying in general, I would say. But config itself is like, it's not really a root cause of any failure. What was actually the root cause is that we weren't keeping what was in the environment in sync with what was in the package. So we might have problems with the database. Maybe like we created a new table that the application needs to use, but we weren't referring to it correctly. Or we also had to deal with the dependencies. So we had to make sure that all the database stuff got deployed before the app itself got updated. And that isn't specific to like databases or even backing services in general. We got the same problem with config files. So on the project that I spoke about, we would put in like different parameters so that we could, for example, we could like specify the amount of memory that was used in different environments differently, or CPU, and things like that. So what did we learn from that? Well, the errors occurred because we didn't have a holistic way to manage the two things. We had this kind of artificial separation between environments and the package, and we actually was beginning to see that those two things are very closely coupled, and they actually evolve together. So what we wanted was a package that can know about all the different resources in the environment. So a package that like has Terraform resources, the resources depend on each other, and then the application code is also included inside the package, so that we know that the application matches with all the different resources that surround it. Another nice property of packaging like this is if we specify the target environment, then because we've baked everything into this package, even the config profiles, then when we are building the package, then we also get some idea that that the config that we have is valid. Because the links are specified in a defined language, we can validate that the links resolve correctly. And we don't have to actually go and try and do the production deployment before we see the errors, which is not ideal. So we've got that package now, and I want to show you a bit of what it looks like in an actual pipeline. So this is the pipeline from before, building on what we think some of the best practices are normally. So I want to call out this bake and push section, because normally we would build the Docker image here and push it, and we're still going to do that. But I've got this concept of like a Terraform package, and that will reference the Docker image using the same application version. But we're going to build and push that as a separate artifact. And then instead of deploying using kubectl like we did before, then we're going to deploy using Terraform. So we're going to then fetch that package for each environment, and we're going to deploy it. So for this example, I've got two different environments. I've got one that is being deployed to from Travis. So that's a test namespace in Kubernetes. And then I've got a separate namespace, which is the production environment. And we've also got some things on GCP, which we'll come to later, which will represent like the database from our example. So in order to demonstrate it, then we need to push some changes through the pipeline. And I'm going to push like a pretty simple change. So I started out with a hello world app, completely stateless. All I had was like just the app itself running in Kubernetes. I deployed that manually into the Kubernetes prod namespace. So that's the version we're on. Just after that, then I started creating a separate version. I created a feature branch, checked in a whole load of guestbook code. This adds a database. I merged that into master. So it already ran through the pipeline. And we'll see it is in the test environment. So from the package view, this is what it looks like. Like in the initial version, then we did not have a database. We're using this app version 79, which will be the same as the Docker image and this package. And then we're going to update. Everything else is going to stay the same. The version number changes. So that does mean that the version number of the Docker image in the deployment manifest will also change. And now we will see the database. So if I switch across, then I should be able to show you some demos. So the first thing that I want to show you, hopefully you can all see that, okay, is so I need to fetch the package first. So this is what fetching the package looks like. Hopefully it looks pretty similar to if you do like a Docker pull. But when I fetch it, then I'm copying the files into this folder. So this folder contains this Terraform package. And then I've got some definitions like for the different environments in here. But the infrastructure description itself, kind of like the contents, the main contents of the package, the stuff that was inside like the inner circle of the diagram, is in the module folder. And let's see. So we see kind of the same stuff that was on the slides before. So this is from Terraform's description of the desired state. The record, we've got the service. And if I scroll down a bit, then we can see that we've also got the manifest for the app deployment. So that's a template file that we're feeding in some variables to. And the important point to get the validation that we wanted is that we've got links between these different records. So if we don't include the links in the config file, then we won't get the same kind of validation that we want. But this one, for example, it's referencing the Kubernetes service. So that's good. So if I now need to show you the production version. So we can see that it's running already. Let me just try and hit that refresh, so hopefully it still works. So in the production environment, we had that package 79 deployed. So if you believe me when I said that I deployed it before, then it should be the same package that's here. So that if we retry the deployment, we should see that nothing will change. And so in order to do the deployment, here I'm using Terraform workspaces for deployments, which basically means that we use the same config each time, but we keep a separate state. So we can evolve the environment separately. And we can also choose some of the configs based on like the workspace name, which in this case is just going to be prod. Workspace, select prod. So if I run the Terraform plan, it's going to show me what it would do if I were to attempt the deployment again. Oh, wait. Why? Okay, I need to export the environment variable, but Okay, this one's in the same folder. So if I run the plan over here again. Oh no. That is not great. Hold on. Does anyone remember the command to unlock the state by any chance? Okay, eventually, hopefully this works. Yes, so no changes. That was all we wanted to see. Okay, so let's move on. So we pushed a new version through. So I want to let's just look at the difference in the actual code. Oh, so everything occurred in the last commit. And we can just see that we added a bunch of database-related resources. So the majority of this stuff is related to IAM permissions we need to communicate with the database, but the module itself just shows that we're creating a database. Yeah, and we also have a corresponding change in the app to plug in the connection name, which is over here. And Kubernetes manifests also get updated. So when I pushed that, then it kicked off this Travis build. And that's doing loads of stuff. But the kind of interesting thing about the publishing is that if we look at the travis.yaml, sorry, not the travis.yaml, it's calling out to another script. So we do the normal publishing. So that's this publishing the package. And then we do the test deployment. And then the command of Terraform validate can also validate the production config is valid, which is like the additional checks that we get because we described everything with Terraform. And so finally, we should now see that the guestbook is running in the test environment. You can access that. And if I'm still in the prod workspace, I think I am. Oh no, I'm not. Oh, this is in the wrong. You always need to be in the right directory to run the Terraform files. It does help. So if I'm in the package directory, then I'm in the prod workspace. And did I fetch the updated package? Maybe not. Let's target. So we've now got the updated package, which corresponds to the Git diff that we just saw that was pushed through Travis. And now if I apply, then we'll get the same changes being rolled out. So these are all the module Postgres-related changes. And then we can just deploy them. So I can't show you this working because it's going to deploy the database, which will take like another 5 minutes. And I'm already way over time. So if I just come back to the final slides. So I have one slide that shows that actually the things we're deploying are rather complicated. And that's about, I guess, all you can take from this slide. This is like a logical view from Terraform. But anyway, thank you for listening. I hope you got something out of it. The code is all on GitHub if you'd like to take a look at it. If you have any questions, please come and ask me. We're already over time, so I'm going to stop now. Thank you.